going to attempt past paper questions related to chemical changes. A student investigates different type of changes by performing four experiments. The student dissolve NaCl in water and observe the salt disappears. Classify this change as physical or chemical and justify your answer in terms of molecular interaction. So dissolving NaCl in water is a physical change. That is a physical change. Why? Because no new substance is formed. Because no new substance is formed. Then next question says that the student places a strip of magnesium in HCl. So magnesium in solid state that reacts with HCl. So it is going to form magnesium chloride in aqueous form plus production of hydrogen gas. So they are asking us that identify the gas produced and explain why this evidence of a chemical change. So gas produced is hydrogen, and why it's a chemical change? Because bonds are broken and reformed as well, and reformed as magnesium reacts with hydrochloric acid. The student melts iodine into purple liquid. Explain why this is a physical change at the molecular level. It's a physical change. Because no bonds are broken or formed at the molecular level. A student burns ethanol and collects the product in a cold test tube where condensation forms. So write a balance equation of the combustion reaction and identify the substance in the condensation. So when ethanol has been burned in the presence of oxygen, then it is going to form carbon dioxide and water vapors. 3CO2 plus 3H2O, and that's going to be 3O2. So the substance in the condensation is going to be water. So we can say the substance in the condensation is water. In this second question, a student performs two experiments. Experiment 1, a piece of zinc metal is added to HCl. So when zinc in solid state is added to HCl, it's going to form zinc chloride and hydrogen gas. So they are saying identify one visual piece of evidence from experiment 1 that suggests a chemical change has occurred. So when a gas has been formed, there is going to be the formation of bubbles, which shows that the gas evolved. So this is going to be the physical evidence that chemical change has occurred. The temperature of the solution rises during experiment 1. What does this observation indicates about the sign of enthalpy for the reaction? So it shows that the reaction is exothermic. Why the reaction is exothermic? And we can see that delta H is negative. In experiment 2, bubble also form. Why this is not a evidence of a chemical change? Because the reason is that the boiling occurs in experiment 2, and boiling is a physical change because no new substance is formed. Is a physical change, is a physical change because no new substance is formed. Write a balance equation for experiment 1 when zinc reacts with HCl. So zinc in solid state that reacts with HCl in aqueous form, and they are forming zinc chloride in aqueous form plus hydrogen gas, and 2HCl is there. So this is a balanced chemical equation. So a student investigate a precipitation reaction between lead nitrate and aqueous potassium iodide, forming a yellow precipitate of lead iodide. So what happens when lead nitrate in aqueous form is reacting with potassium iodide in aqueous form? They are forming yellow precipitate of lead iodide. Like this, lead has been combined with iodide and remaining is going to be potassium nitrate. So in order to balance it, this is in solid state, in order to balance it I need to put 2 here, and I also need to put 2 here as well. The student is asked to write the complex ionic equation and net ionic equation for this reaction. So how can we write it? Like, we can first write the reaction here and split it into ionic form. We know aqueous can only be split up, so Pb plus 2 plus 2NO3 minus plus 2K positive plus 2I minus, they would be forming PbI2. It's in solid form, so it will not be split up, plus 2K positive plus 2NO3 negative. It's in aqueous form, and that is in aqueous form, aqueous, and aqueous. So the same is going to be cancelled from both sides, 2 nitrate, and the remaining is going to be Pb plus 2 in aqueous form plus 2I minus in aqueous form, and they are going to form PbI2 in solid form. The student stirred the precipitate for 10 minutes and it does not dissolve. Explain why PbI2 remains as a solid after dissolving as well. So the reason is that its lattice energy is the energy needed to break the ionic bond. So we can say that its lattice energy is too strong for water molecules to break apart. This reaction follows the law of conservation of mass. Explain how the particulate level changes in this reaction demonstrate the mass conservation. So law of conservation of mass states that the mass remains same before and after the reaction. So the reason could be the same number of Pb plus 2, I minus, and potassium ions and nitrate ions exist before and after the reaction. Before and after the reaction. In this question, they are saying a student is given a sample of solid sodium bicarbonate and add HCl in it. So we have to write the balanced molecular equation when sodium hydrogen carbonate in solid state is reacting with HCl in aqueous form. They are saying it is going to form carbon dioxide and water and an ionic compound. So ionic compound is when sodium reacts with HCl, so it is going to form sodium chloride. It's in gas form, and this is water which is in liquid form, and that is sodium chloride in aqueous form. So this is going to be formed in this reaction. So in this question, they want us to draw a particulate diagram to represent the species present before and after the reaction in the solution. So before the reaction, if you see, there is sodium ion, there is hydrogen ion. Oh, this is HCO3. So it's going to be hydrogen carbonate. That's going to be hydrogen carbonate. So these both ions are present in NaCO3. In HCl, it is hydrogen ion and chloride ion. So I have just shown it here that these ions are present before, and after it is going to be CO2, H2O, and in NaCl it's going to be Na positive and chloride ion, which I have shown in this beaker. So next question says that why, like explain why this is a chemical change using evidence from molecular arrangement. So what happens, that we can see one thing, that CO2 gas escapes the solution. So what happens, CO2 gas escapes the solution, demonstrating a change at the macroscopic level. A student investigates the several changes that occur when substances interact in the lab. Each process is analyzed at the macroscopic and molecular level. So when NaHCO3 is added to vinegar, which is CH3COH, bubble is observed and a colorless gas is released. So what happens when NaHCO3 is reacting with CH3COOH? So they are going to form first sodium ethanoate, CH3COONA plus water plus carbon dioxide is formed. They are saying explain why this reaction is classified as a chemical process. So first of all, the first reason we can say chemical reaction involve bond breaking and bond formation. HCO3 minus loses a proton. HCO3 minus in this, that loses a proton and becomes CO2, and H2O as well. So this is new covalent bond form. On the other hand, you can see that CH3COOH donates a proton and becomes CH3COO minus. That means acetic acid is changed to acetate. So the next question says that write a balanced chemical equation. For this we have already written the balanced chemical equation. This is the balanced chemical equation. We can just copy it and paste it here. Yeah. Write the corresponding complete net ionic equation for this reaction. So we know this is basically in aqua, this is in the solid state. Just first when we can write the net ionic equation, just wait please. So the student notices that the reaction between mixture feels cooler after NaCO3 is added to CH3COH. What does this temperature change suggest about the reaction? As the reaction feels cooler, so we can say that it is going to be endothermic. Endothermic because energy is absorbed from the surrounding. They are saying hydrogen peroxide decompose into oxygen gas. So this is hydrogen peroxide that decompose to form water and oxygen gas. So this is going to be 2H2O2 and 2H2 plus O2. Okay. So they are saying why the net ionic equation for this reaction is identical to the molecular equation. The reason is that there are no spectator ions present. That is why their molecular equation is equal to net ionic equation. A student analyzes a particulate model representing this reaction. Identify two essential features that must be present for the model to accurately depict the reaction. So hydrogen peroxide molecules, these molecules breaking apart into separate water and oxygen molecule, separate water and oxygen molecule, and oxygen which formed as O2 molecules, that is must, not individual atom. So next question says that magnesium reacts with HCl in a flask and collects the hydrogen gas we have to write the balanced chemical equation. Mg plus 2HCl is going to form magnesium chloride plus H2 aqueous gas, and this is going to be aqueous, this is going to be solid state. A student determines the actual yield of hydrogen is 87.5% of the theoretical yield. Calculate the actual mass of H2 collected. So first of all, we have to find out the moles of magnesium. So in order to find the moles of magnesium, formula is mass over molar mass of magnesium, which is going to be 24.31. The answer comes out to be 0.1029. So you can see magnesium and hydrogen is 1:1. So it is going to form 0.12029 moles of hydrogen as well, because the ratio is 1:1. So now what we need to do, I'm first going to find the mass of hydrogen by multiplying its mole with the molar mass, that is 2 and 2.016, and that comes out to be 0.2075 grams. And you know the actual yield of hydrogen is 87.5% of the theoretical yield. Theoretical yield is 0.2075, and the answer that comes out to be how much? It's 0.1816 grams. And the student notices that the actual yield is lower than the expected. Identify one possible source of error and explain it would affect the yield. So that could be like hydrogen gas that escapes before measurement, resulting in less gas being recorded than was actually produced. Next question says that explain how mass is conserved in this reaction at atomic level, because what happens, the number of magnesium Cl and hydrogen atoms remains unchanged before and after the reaction.